Good afternoon, class. We are looking at section 3.3, basic differentiation formulas. So we looked at derivatives using definitions. We started with the definition of a slope, rise over run, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We looked at them from a different point of view, depending upon how you write it. For example, a and x here gives rise to this formula. If you have this distance of h gives rise to this formula. And if you call this b, therefore it's f of b gives rise to this formula. All of them are rise over run. Given 2 points, find the equation of a secant line. Now, as q approaches p, we get to the red line, which is the tangent line. And therefore, we can find the slope of a tangent line as the limit of the slope of the PQ as Q approaches P. We go with this formula, X approaches A, in this case, H approaches 0. And so that's F prime of A, or M. We have different ways of writing formulas for lines. If we use the point slope, and we use this pair A comma F of A, it gives rise to the formula for the tangent line. In general, we use differentiation formula. F prime of x is the limit of f of x plus h minus f of x over h as h approaches 0. That's the definition. And now we want to go to basic differentiation formulas. We start with the constant. F of x or y equals c. It's a constant. We know any constant is a horizontal line, and any horizontal line, its slope is 0. So this is one way to approach that graphically. If we go with the definition, f of x plus h, where f of x is c, that's just c because it's independent of x. C minus c becomes 0. 0 over h is 0. And now you take a limit, becomes 0, which gives rise to the derivative of any constant is 0. In other words, if I give you a number, y equals 5, 10, negative 2, you name it, its derivative is 0. We recall the compound interest. This was the simple interest. I equals PRT. The amount A would be P plus PRT, where P is the principal, R is the rate, T is time in years. And the same thing here. The only difference is N is the compound interest. A equals P times 1 plus R over N to the power of NT. N is the number of times compounding takes place per year. So when it's just once, becomes the same formula as here. But for example, if it's semi-annually, N is 2. If it's monthly, it's 12, and so on and so forth. Now, if we let M represent the reciprocal of this N over R, then the reciprocal of M, 1 over M represents R over N, and the cross product N becomes Rm. I'm reminding you of what we did in college algebra and pre-calculus in this case. So we're going to replace the R over N with 1 over M, and N times T is R times M times T. So N times T is R times M times T, and we put the M here. This is the product of all of them. Now this portion, when the compounding happens indefinitely, continuously, this changes to E. Therefore, this gives rise to the definition of E. E is the limit of 1 plus 1 over M to the power of M as M approaches infinity. Now, of course, you can use any variable instead of M. Now, if we replace the 1 over m with h, let's say, then we replace the m with h, and when m goes to infinity, 1 over m or h goes to 0. So I want you to see what happens here. I want you to look at this formula. If you replace 1 over m with h, then you have to replace m with 1 over h. If m is approaching infinity, h is approaching 0. And as you know, e is an irrational number. 2.71828 continues indefinitely. And so we have the two definitions. This was from algebra. And this one, we will look at it later on, and we look at the proof of that, in fact. So the limit, e is such a number that the limit of e to the power of h minus 1 over h as h approaches 0 equals 1. So that's another way of approaching it. Now, here's the power rule. The derivative of x to the power of n is nx to the power of n minus 1. Some of these formulas you already know, which means n becomes the coefficient and the exponent goes down by 1. And if you apply that to x becomes 1, if you have a constant times f of x, you can take the constant out when you differentiate. The derivative of a sum is the sum of the derivatives, and the derivative of the difference is the difference of the derivative. So we have many formulas. We're not going to look at all of them at the same time, but the derivative of a constant is 0. The derivative of x to the power of n is nx to the power of n minus 1, known as a power rule. This is extremely important. The derivative of k times x equals k. We are assuming k is a number. So for example, 5x gives you 5. The derivative of e to the power of x itself, sine is cosine, cosine is negative sine. We will look at the rest of them later on. But for now, we are concerned with the first few. And although you're not responsible for the proof, I'm going to go over the proof for f of x equals x to the power of n. In other words, the power rule. The derivative of x to the power of n is nx to the power of n minus 1. And so let's go with the definition. And according to the definition, f of x plus h would be x plus h to the power of n. This is itself and over h, so that's that. Now what we want to do, I want to remind everybody what this is and expand that. So I'm going to remind you of a couple of things. We discussed n factorial in algebra, which means n times n minus 1 all the way to 1, and 0 factorial equals 1. And we have the binomial theorem. A plus b to the power of n is n0. This is combination of n0, a sub a to the power of n, b to the power of 0. Combination of n choose 1, a to the power of n minus 1, b to the power of 1, all the way to the n. Now, this is the formula for the combination. Again, just to remind you, okay? N choose r is n factorial over r factorial times n minus r factorial. I'm just reminding you of what you have studied. Couple of simple examples of that. You all recall a plus b squared is a squared plus 2ab plus b squared. It follows that. A plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. Follows that. If we work this out, everybody, okay, this becomes 1, this becomes n, this also becomes 1, okay? So if we work this out, n factorial over 0 factorial times n minus 0 factorial. So the first one becomes 1 because this is n factorial, they cancel each other. If you work it out, this becomes n. If you work it out, this becomes 1. And the one before that becomes n. So you may recall those. So what we are going to do, we are going to write the expansion of this in the following format. This, we know it to be 1, and this we know it to be n, right? And this one, I'm going to keep it as n2. That means combination of n choose 2. Needless to say, I can evaluate it. There's no need for that. You'll see in a moment why I don't do that. So I write this one is h. This one has h squared all the way to the last one, h to the power of n. These two cancel each other. So we are left with this. And take a look at what is left in the parentheses. I can take a common factor of h out. When I do that, this h goes away. This h squared becomes h to the power of 1. And in other words, you take 1 from the exponent. So this becomes n minus 2, this becomes n minus 1. So take a look. N minus 1 becomes n minus 2, n becomes n minus 1 when we factor out the h. The h drops. So we have the limit as h approaches 0 of what's left in the parentheses. And notice this has h to a bigger power, this has h to a bigger power. All of them have h, all of them go to 0 with the exception of the first one. And that's the proof that f prime of x is n x to the power of n minus 1. This is known as a power rule. Again, you're not responsible for that. What you need to know is this. If this is f of x to the power of n, this is its derivative. That's all you need to know. For example, x to the power of 6, very simple. And I know many of you know that. Then f prime, you take the 6 and make it the coefficient, and then take it down by 1 according to the power rule, and it becomes 6x to the power of. Very simple. Can anybody tell me what's the answer here?
1000x to the power of 999.
Perfect. So 1000 becomes the coefficient. According to this formula, 1000 becomes the coefficient. Then you take it down by 1, and the answer is 1000x to the power of 999. What about here? Y equals t to the power of 4, everybody. What's the answer?
4t to the power of 3.
Excellent, excellent, excellent. Now, what I want to mention here, this is the Leibniz's notation. dy dt is telling the reader that t is the independent variable. If I wanted to do it here, I would write dy dx. What about this one? What would be the derivative of this guy? 3r squared. Three remains, and r squared, you take the 2 down, and r to the power of 2 minus 1. The final answer is 6r. Again, I want you to notice dy dr is telling the reader r is the independent variable. This is another way of writing it, ddr of 3r squared, which becomes 6r. For this one, what's the answer?
60x to the power of 5.
Beautiful. Because f prime is 10, and then x to the power of 6 gives us 6x to the power of 5. That's the final answer. So very straightforward, everybody. Okay, we can do this pretty fast. Let's give everybody a quick moment to find the derivative of this expression. We want f of x, given f of x. This is f, everybody. Given f of x, find f prime of x. F of x is x to the power of 8 plus 12x to the power of 5 minus 4x to the power of 4 plus 10x cubed minus 6x plus 5. So that's f of x. And we want to find f prime of x. Let's go one by one. This 8 x to the power of 7. This one 12 and 5, their product is 60 x to the power of 4 minus 4 and 4 minus 16 x cubed. 10 and 3, the product is plus 30x squared minus 6x gives you minus 6. A constant gives you 0. And that's the final answer. So I wanted to make that change. So this is f of x. And this one is f prime of x. All right, you may recall that we did this in a previous section. Very simple. According to this formula, this is 5, this is 0, so simply put f prime of x is 5. To do this, I want to use the power rule. The way it's given, I can't use the power rule. What should I do? Anybody? Algebra. What should I do so I can use the power rule?
Bring the x up, but make it a negative exponent.
Beautiful, beautiful. Here's the negative and positive exponential rules. A to the power of 0 is 1, a to the power of m times a to the power of n, you add up. This is the product rule. A to the power of m to the power of n is a to the power of m, and this is the power rule. This is the quotient rule. A to the power of m over a to the power of n is a to the power of m minus n. If you have a negative, a to the power exponent, a to the power of minus n is 1 over a to the power of n. 1 over a to the power of minus n is a to the power of n. A over b to the power of minus n, you can flip it over to the power of n. So those are the rules we should know. In this case, we're going to write 2x to the power of negative 1. And now we can differentiate it as follows. Which becomes negative 2x to the power of negative 2. And we are going to take the negative 2 down, make it positive, becomes negative 2x squared, according to those negative exponential rules that we should be very comfortable. This one is very straightforward. 7 times 2, 14. So 14x is the answer. All right. In order to use the power rule, first we're going to change this. Square root of x is x to the power of 1/2. The nth root of a is a to the power of 1 over n. Of course, you got to pay attention to n if it's odd versus even. And if you have the nth root of a to the power of m is the nth root of a to the power of m, or a to the power of m over n. These are some of the rules that I just wanted to remind you. So you change that to x to the power of 1/2, and then you apply the product rule. This is to the power of 1, everybody. When we don't write an exponent, the exponent is 1. 1 and 1/2, according to this one, we want to add them up. So 3/2, 5x minus 2. Now this is very simple. 3/2, x to the power of, take away 1 becomes 1/2 plus 5. So class, 3/2 minus 1. 3/2 minus 1 is 1/2. And if you want to go back to the format we received, it, this is square root of x. So 3/2 square root of x plus 5. And that's the final answer. Okay. Can anybody tell me what's the answer here? Very carefully. Look at this, and so you can make a proper decision. d dx of pi squared. Pi squared, like pi, like e, like 1, like 10,000, like negative 1/3 is a number. Perfect. Therefore, the answer is 0. You should notice this is a number in any format. Any number, the derivative is 0. So you are dealing with this case, everybody. The derivative of a constant. All right. This page, again, we want to use the power rule, we can't. And this one, we write it as x to the power of -5, which is algebra. Now we use the power rule. -5, x to the power of -5 subtract 1. And this is the only calculus step, everybody, which becomes -5, x to the power of -6. And we finalize it in this format. For part B, again, we want to use the power rule. The way it's given, we can't. So we have to change it. How would you change that so you can use the power rule? Anybody? Simply put, we bring x cubed up, becomes 2/7 x to the power of -3. F prime is 2/7 times the exponent -3, x to the power of the exponent -1. And again, calculus step. I put the asterisk next to it, and we're done with calculus. Now, algebra. -6/7 x to the power of -4. I'm going to take this down and make it x to the power of +4. This is the final answer using the power rule. Part C, again, the way it's given, I can't use the power rule. So to use the power rule, I'm going to work on these two and make it x to the power of -4. Now I can say f prime is 2/9 times the exponent -4, x to the power of the exponent -1. That gives me -8. And again, this is the only calculus. -8/9. X to the power of -5. I take it down. And it becomes -8/9 x to the power of +5. Notice the process we take in order to be able to use the power rule. Same thing happens here. This you have seen it. We change it to x to the power of 1/2. And we write f prime is 1/2 x to the power of 1/2 -1. And as you can see, this was the only calculus step. And so you take it down, make it x to the power of +1/2, which is the square root of x at the bottom. Again, the way it's given, I can't use the power rule, so I'm going to write 2 x to the power of 4/5 I'm going to use the power rule on that. F prime of x is 2 times 4 over 5. X to the power of 4 over 5 minus 1 is the one and only calculus step. This is equal to 8 over 5. X to the power of negative 1 over 5. Now negative 1 over 5 goes down, becomes x to the power of positive 1 over 5, or the fifth root of x. So f prime is 8 over 5, the fifth root of x. I hope you see how easy we can come up with the answer as long as we know the prior knowledge of mathematics. One step of calculus, one step of calculus. Later on, we will learn about the quotient rule, and it is extremely important to know when to use it, when not to use it. In other words, if you must use the quotient rule and you don't use it, most likely you make a mistake. If you shouldn't use it and you don't recognize the algebra behind it, probably you make a mistake. So here's the process. You make up two fractions. This is 1, which gives you 10, minus this is 1, which gives you minus 7x. And now, as you can see, this gives you 0, this gives you minus 7, and you're done. So very fast, you end up with the proper answer because you knew what to do. And that's the idea. Be very careful with your techniques and, of course, your algebraic techniques. We want to find the equation of a tangent line. And now, of course, we are going to take the easy way out. Instead of the definition, we're going to use the formulas. In order to find the tangent line, we need two things. We need the pair and we need the slope. To find the slope, we differentiate this. And of course, now we know how to do that. So f prime of x is 2x minus 3. If I want my pair x comma y, only x is given. If I put the 4 here, I get 4 squared, which is 16. Minus 3 times 4, which is 12. Minus 1. And I get my pair 4 comma 3. And if I want my slope, f prime of 4, 2 times 4, 8 minus 3 is 5. Now, elementary algebra, y minus y1 equals m times x minus x of 1, which means y minus 3 equals 5 times x minus 4. And it gives me 5x minus 17. Again, quickly, this is 5x minus 20. This is plus 3. Now, remember this pair belongs to the original function. Also belongs to the point of tangency. Therefore, it belongs to the equation of a tangent line. If you plug in this pair, it works. And it doesn't mean that we got the slope right. It means this process is done correct, and it is. So pay attention to that. Find the points for which the tangent lines are horizontal. Speaking of the tangent lines, to discuss that, we can discuss the slope of a tangent line, which comes from the differentiation. So we are going to differentiate this. This is the easy differentiation using the power rule, 3x squared minus 6x. That's f prime of x. When it says horizontal, it's giving us the slope. The slope of any horizontal line is 0. Now, it's the same as saying find the points for which the tangent lines have a slope equal 7. Then you would put this equal to 7. Have slopes equal to negative 4. You set this one equal to negative 4. So because it's horizontal is 0, it's a simple work. You factor the 3x out. So x is either 0 or 2. And it is important to know this is a different point than this one. If you want to pair, plug in 0, everything goes to 0, you get 0, 5. Plug in 2, 2 cubed is 8, minus 3 times 2 squared is 4, which makes it 12. So we have 8 minus 12, which makes it minus 4, plus 5 is positive 1. So this is the second pair. There are two pairs here. All right, we want to find the derivative of a exponential function in the form of f of x equals a to the power of x, and we are going to go with the definition. So if you use the definition, you get the limit of a to the power of x plus h minus a to the power of x over h as h approaches 0. Again, just pay attention to the process. You're not responsible for the proof. Everything is given to you. You have access to it. Just if you can follow it, it makes it that much easier understanding the concept of a definition. Okay, class. So with that being the case, we recognize this is a to the power of x times a to the power of h. Therefore, between these two, I can take a to the power of x out. Notice the limit is the limit of h approaching 0. Anything involving h remains, but you can take out a to the power of x outside the limit because, as I mentioned, the limit pertains to h only. Now, when you compare these two, you notice f prime is the same thing times some limit. So what if there was some number a such that this limit was equal to 1? That would be interesting because in that case, the function and its derivative become identical. So numerical analysis gives us the answer. So we start with number 2. And in this case, remember, we want the limit as h approaches 0. The numerical analysis starts with numbers close to that, in this case 0, like 0.1, 0.01, 0.001, and does the job. And it becomes closer and closer as far as number 2 is concerned. This is what we get. And by the way, even if you want to get closer, you can go with 0.000, another 0, and then 1. And by the way, with the limits, we go with both sides. But in this case, one side is enough for the purpose of getting to the number we are interested in. And notice when a is 2, right? When the base is 2 here, 2 to the power of h, then, and by the way, this is f prime of 0 because if you plug in 0 here, this becomes 1. So f prime of 0 is this limit and seems to be this, and we're going to write 0.65. If you work on number 3, everybody, and again, you plug in this one into this, okay, then in that case, we seem to be getting close to this number, which is 1.10. Notice number 1 is between these two numbers, isn't it? Therefore, the number that its limit ends up being 1 must be between these two numbers. So somewhere between 2 and 3. Some of you already know it's 2.71828 and it continues indefinitely. But the numerical analysis finds that number. And so this is another definition for E. The limit as h approaches 0 of e to the power of h minus 1 over h must be 1. So that number is E. And so geometrically, what does it mean? This means that of all possible exponential functions of the form y equals a to the power of x, the function f of x equals e to the power of x is the one whose tangent line at 0, 1 has a slope of f prime of 0 that is exactly 1. If you draw 2 to the power of x and 3 to the power of x, and as you know, the base, the larger the base, the closer to the y-axis. Y equals e to the power of x is between the two. And for that one, at this point, the slope is 1. So we said f of x equals a to the power of x. Here's f prime of x. If you set x equal to 0, this becomes a to the power of 0, which is 1. And therefore, f prime of 0 is 1 times this. So f prime of 0 is the limit of a to the power of h minus 1 over h as h approaches 0. So f prime in general is f prime of 0, a to the power of x. And as it was mentioned, we had seen this from algebra, and I went over that also. And the definition of E besides that takes this one, which we just proved it, and we're going to say all you need to know. If f of x is e to the power of x, so is f prime of x. That's all you need to know to move on as far as the course is concerned. Now we want to differentiate, given f of x equals e to the power of minus x, we want to find f prime and f double prime. So this concept of f double prime, I want to explain it to you. It's known as higher order derivatives of f of x. The derivative of a function y equals f of x is itself a function. Y prime equals f prime of x. Therefore, you can take the derivative of f prime of x, referred to as the second derivative of f of x. We say f double prime, or we put f and a number in a parenthesis. Sometimes they use brackets of x. This differentiation process can be continued to find the third, fourth, and successive derivatives of f of x, known as higher order derivatives of f of x. Using the prime, notation for derivatives would eventually become somewhat chaotic. We use the numerical notation f, and then inside the parentheses n. That doesn't mean the power. That means the derivative of x to denote the nth derivative of f of x. So first and foremost, f prime, e to the power of x is itself, minus x is negative 1. So I just wanted to mention this concept of f double prime. So the second derivative, differentiated again, and as you know, e to the power of x gives you e to the power of x. So simply put, do it again. That's the concept. What about sine t plus pi cosine t? We want to differentiate that, and the derivative of sine x is cosine x. So the derivative of sine t is cosine t plus pi times. The derivative of cosine x is minus sine x. So for this one class, only for this one, we get plus pi times. Cosine gives us negative sine. So we get cosine t minus pi sine t. We want to differentiate h of t equals the fourth root of t minus 4e to the power of t minus cosine t over 2. And to do that, the first thing we need to do, we need to change this so that we can use the power rule on that. So we're going to change this to t to the power of 1/4. Now, if you see this and what it represents, fine. If you don't, we're going to change this to minus 1/2 times cosine t. Again, just so we can recognize the answer. What happens here? We get 1/4 t to the power of 1/4 minus 1. This one is itself minus 4e to the power of t. And this one is minus 1/2 cosine gives you negative sine t. So plus 1/2 sine t. Again, this one, 1/4 t to the power of 1/4 minus 1. This one is itself minus 4e to the power of t. And this one minus 1/2 cosine gives you negative sine. So negative times negative makes it positive 1/2 sine. So these two are very simple. You write this one and you write this one. If you want to write in this format, we would put plus sine t over 2. This one is negative 3/4. So it goes down. Maybe I write this. This we can rewrite it as 1/4 t to the power of positive 3/4. I hope you see tons of algebraic steps. And so change that to the format that it was given. This means the 4th root of t cubed. So this becomes 1/4, the 4th root of t cubed. This is itself minus 4 e to the power of t. And this one, if you want to write it in the same format, plus sine t over t, or over 2, or just write it in this way, it doesn't matter. It's your choice. The distance in meters of an object from a starting point is given by s of t equals 2t squared minus 5t plus 4d, where t is time in seconds. What is the velocity of the object from 2 to 4 seconds? Remember, we have done this question, exactly the same question, which is discussing the average velocity. Anytime you have 2 points in time, it's average velocity. So it's s of 4 minus s of 2 over 4 minus 2. You can find it in your notes. We evaluate this function at 4 minus, we evaluate the function at 2, their difference over 4 minus 2 or 2, and we get 7 feet per second. I hope you remember that. Part B, what is the instantaneous velocity? Up to here, we had done it. Now the acceleration is new, and what is the velocity after 6 seconds? So first I want to remind you of what we did. The difference is now we can use the formulas. So v of t is s prime of t, okay, which is 4t minus 5. So this part, we had done it with definition before. Now we did it with the easy way out. Now, the new stuff, what is the velocity after 6 seconds? If I replace this with 6, 4 times 6, 24 minus 5, 19 meters per second. Acceleration is the second derivative of the position function. Acceleration is v prime of t or s double prime of t. So just differentiate this again, which gives you simply 4. And because 4 is independent of t, then at any time, whether it's 6 seconds or not, the acceleration is 4 meters per square second. I'm going to discuss the units in a moment, but before I do that, notice 4 is independent of t. If it wasn't, we would multiply, we would put the t. Let's say it was 4t, we would say 4 times 6. It's not, so it's a constant acceleration. As far as the units are concerned, velocity is ds over dt, units of distance over units of time, and it makes it meters per second. Acceleration, dv dt, units of velocity, meters per second, over units of time, second, and this is the same as meters per square second. When does the object reach a velocity of 31 meters per second? Well, you set this one equal to 31 and solve. So if I set this equal to 31, I get 4t equals 36. If I divide both sides by 4, t becomes 9 seconds. T becomes 9 seconds.